Lovely. All right, we're just about to get started. Good morning and welcome everybody that's just about to join in. Welcome to our CMAA webinar on the design and specification on permeable interlocking and segmental concrete pavements. Everyone's obviously just joining in now in these first couple of minutes. So if everyone can hear me all okay, if you just want to put a little message in the chat box saying that everything's working, that would be wonderful. Means that I've got everything right. Morning, I can see some messages popping up. Thank you, everybody. It's looking good. Good morning to everyone that's joined, or good afternoon, or depending on where you are. I know we've got some people from Eastern Australia, some people from the West Coast, and also a few people joining in from international locations as well. So thank you all for coming. I'm just going to give everyone a minute or so to join in. So before I start, I might just do a bit of housekeeping, everyone. So to sort of, if you want to actually make the slides a bit bigger, you can actually pop the chat box out using the square and the arrow in the top right-hand corner. That'll mean that you can see all the content a little bit easier. Also, when I get into the nitty-gritty of it, I'm going to hide my camera as well, so you won't have to look at me. But you can see that, again, you'll be able to see the slides in greater detail. So just a little bit of housekeeping for everyone there. And Sam, in answer to your question, no such thing as a stupid question. This is technically episode 4 of our CMAA Council webinar series. So we actually ran 3 episodes last year and the start of this year. And we've picked it back up again due to popular demand, and we're hoping that we can give you all some great information on some permeable interlocking concrete pavements. So, wonderful. Alrighty. Well, look, while everyone's joining in these first couple of minutes, I think I might get this show on the road, just in the interest of time. And at this point, I'd like to also mention that we have Keanu, one of our engineers that works with us at CMAA and also works at AECOM. Fantastic bloke. He's actually in the chat box at the moment, and he's going to answer any questions you might have. So feel free at any point to ask questions. I'll endeavor to answer them at the end of this webinar, but Keanu will also be there as well. And in answer to your question, Ken, yes, there will be a recorded version of this that you'll be able to distribute out. So anyone that's unable to make it will definitely be able to pass this along to them. So myself, my name's Jack. I'm a civil engineer here with CMAA, and I'm going to be taking you through a little bit about permeable interlocking concrete pavements, about why and how we should be using them, and a little bit about the sort of design and specification of these pavements. Firstly, I'd like to acknowledge that this is a webinar format, so I'd like to acknowledge that the traditional custodians of the various lands from which all of our attendees are joining us today, and I'd like to pay respects to those elders past, present, and emerging across the nation. So, look, a little bit about what we're going to be talking about today. Just going to quickly touch on what we do here at the CMAA, what a permeable pavement is and the different types of permeable pavements, why we might be specifying permeable pavements and specifically permeable interlocking concrete pavements, some of their uses, and then we'll sort of go down a little bit into the design and specification considerations. So talking about pavement type, material selection, as well as both your hydrological and structural mechanistic design of your pavement. So I'm hoping this will be a really nice overview of where we're up to these days with permeable concrete pavements in Australia. So look, a little bit about quickly who the CMAA is and what our sort of mission here is. We are the Concrete Masonry Association of Australia, and we represent all concrete block and paver manufacturers in Australia. And it's essentially our job to make it easier to build in block and pavers. We want to, develop talent in the industry. We want to facilitate important conversations by having webinars and discussions such as this. And we also obviously want to promote our members' products. And I can see in the chat box a few of our fantastic members have joined in. So thank you all for tuning in. And obviously your support is much appreciated here. And you can see some of our members here up on the screen and who they are. And I'm sure a lot of you will be familiar with at least a couple of these manufacturers. So definitely make sure after this webinar, if you've got any questions specifically about paver products, all of these people here will be your best bet to reach out to, and they'll be able to give you that detailed information. And on top of that, obviously, the CMAA, as I mentioned, we are an industry association and we're a not-for-profit. So we offer free resources, a free technical hotline, free manuals, free software. So if you ever have any questions about pavement design that you're not really sure of, please definitely feel free to reach out to us as a first point of contact, and we'll endeavour to answer your question or point you in the right direction as well. So, look, firstly, it's worth touching on what a permeable pavement actually is and how they function and what the ideology behind these products actually are and these systems actually is. So any pavement design there's out there, and I'm sure we've got a few in the midst here attending this webinar. Look, generally speaking, the golden rule of pavement design is to never let water penetrate the wearing surface of your pavement. The reason for this is that in a conventional impermeable pavement design, we generally have, base course material and bedding material that has fine particle matter in there that actually gives that material its associated strength. Now, what ends up happening when we get water entering that pavement is essentially you can get this action called pumping, where, every time a tire or traffic crosses your pavement, a little bit of water will enter your pavement surface, and with it, it will pump out or take out a small proportion of those fine particles, or that fine base course and bedding matter. And obviously, with that becomes your actual eventual rutting. So as that material disappears, you eventually get that sort of depression that forms in your pavement, and that's how you get potholes, and that's how you get pavement failure. So generally speaking, this is the rule that most pavement engineers will sort of use as their mantra when they're designing a pavement. However, if we sort of think about what's causing the problem here with this, fine matter getting pumped out of the pavement system and the pavement substructure, we sort of can ask ourselves the question, well, what if we actually removed all of that fine particulate matter? What if we actually used a material that's actually not going to be pumped out? And we can actually determine a system that can work and actually, be able to withstand water entering the system without causing this settlement and this rutting that will cause your pavement failure. So essentially speaking, in summary, permeable pavements break this rule. And you can sort of see a little bit of a diagram below. This was originally a GIF, but the Demio platform has restricted to PDF slides. So I've sort of broken it up into segments for you. You can sort of see how the pavement works. It sort of functions in its steady state. And then as a rainfall event occurs, you actually get rain slowly filling up that system. And you can see that in the second picture. And then eventually what happens is that system becomes saturated with water, and you then have an outlet, whether it's a pipe or whether it goes down into your underlying subgrade. And that essentially acts as a stopgap or a filter mechanism to actually allow water to fill up and then slowly disperse out. So think of it almost like a big bathtub with a drain. That's the analogy that I like to think of. And that's essentially how most permeable pavements work, regardless of the different type of surfacing material you're actually using. So the different types of permeable pavements, there's generally sort of three common types that we see here in Australia that are beginning to be picked up. The first type is an open graded or a porous asphalt. And as the name suggests, it's essentially an asphaltic material that has, again, some of that finer matter scraped out, which allows water to permeate through that surface. Similarly speaking, you've got a no fines or a pervious concrete, which a lot of people here would be familiar with. And again, it's a similar theory as well. It's a concrete that's got a higher void ratio to, again, allow that water to infiltrate through the pavement surface layer. And finally, we have our permeable interlocking concrete pavers, or PICPs, and that's the acronym that I'm probably going to use for the remainder of this webinar. And essentially, as the name suggests, we've got a pavement system or a paver layer itself that interlocks, so you get those units actually tessellating and interlocking into each other. And either through the actual paver itself or through the joints between each of the individual pavers, you'll actually allow water to infiltrate through that surface layer into the underlying pavement substructure. And once again, these photos don't really do it justice. These were originally GIFs that actually showed some in situ trials of pouring water onto these pavements. And it's almost a really satisfying thing to watch, because you see these pavements get completely saturated with water and it just absorbs all of it, just exactly like a sink. So that's essentially how they sort of work and how we see them in action. So, PICPs, it says here on the slides, they're a simple and they're an effective solution, minimizing issues of clogging, which I'll get into in a little bit later, whilst maintaining the durability of your actual pavement itself. And obviously, durability is a massive thing that we need to take importance over. Our pavements need to take the test of time, and they need to last. And so this is where, if we sort of think about how we're treating our pavements, this is where these PICP products are likely to actually come out on top compared to your other systems that I talked about before, such as your porous asphalt and as well as your no fines concrete. So I'll refer to an example that's been down for about close to 25 years now, and that's Sydney Olympic Park. That was laid down on top of marshland, on top of swampland in the late 90s leading up to the Olympics in Sydney. And again, they used a combination of permeable as well as conventional segmental pavers. And you can see now that with good design, with good construction, good specification, and adequate maintenance, you can have a pavement that will easily look as good as it did the day it was laid. And that pavement is approaching 25 years of age. And you can sort of see here what I was talking about before with the widened gaps designed to let water pass through. So you can see these are two products that some of our members actually manufacture here. You've obviously got your traditional sort of rectilinear paver, as well as those sort of funky looking eco trihex pavers from Adbri Masonry. And both have the same functionality of allowing water to infiltrate through those joints and through those gaps. So we obviously sort of have a little bit of an idea of what a permeable pavement is now and how they function. So I guess the next important question that we need to be asking ourselves as engineers, as urban planners, as responsible citizens is why PICPs? What's the win and what's the gain from using these systems? So I've put up a couple of sort of different options here on the screen for you that are, really nice throwaway lines to put in a marketing brochure. But the reality is that all of these things are true and they are all associated with concrete segmental pavements. They are easily repaired and easily replaceable. In the event that you do have damage to your pavement surface, which, we're trying to avoid in the first place, it's very easy to quickly pick up a nodulated unit of these pavers and relay with the same exact type of paver or a similar type depending on your pattern. So unlike a concrete or an asphalt pavement, if you get a failure, if you get a pothole or similar, you then have to actually go back and oftentimes relay a large section of pavement. With these, it's not the case. And again, I sort of spoke to this idea of low maintenance. They are durable products that will last the test of time if they're designed properly. But I think some of the better benefits here is the idea of environmental friendliness, which I'll speak to in the next couple slides, as well as the idea of traffic. So, we want to design precincts and we want to design pathways and urban assets that are safe for people to use. And one of the great benefits of segmental pavers is because of that pre-cracked nature, because of these individual units, you actually get those little bumps where each joint lay. So as you actually drive over a segmental pavement, it actually induces vibrations into your steering wheel. So as a consequence of that, as a driver, you're more likely to sort of monitor your behavior and actually slow down as you enter a zone with permeable pavements. And that's why a lot of the time we'll actually see them used in sort of high pedestrian areas, around school zones, and also in areas approaching intersections where, there is a need to have drivers be more aware of what they're doing. And on top of this, when you lay a permeable interlocking pavement, it's immediately trafficable. You can lay it down, compact it, and you're good to go. You don't have to wait any of that curing time. So it makes for an efficient construction system. But look, let's talk rain and let's talk environmental friendliness and let's sort of talk about the year in review. Let's call it a quick review of 2022 and where we're at. CMAA here, our office is based in Sydney. So I'm going to use Sydney as a bit of a detailed example for where we're at with rainfall. As you can see on this chart, the average rainfall for Sydney is about 1,200 millimetres a year. As of April, I think we've broken that. As of July, you can see we're well above that at 1,500 mil. And as of October, so this is still a month ago, and we've had a lot of rain since then, we were at 2,194 millimetres of rain, which was a new record for Sydney. Not a record that we want to break, but it's one that we have broken in 2022. And it's sort of the same for a lot of cities in Australia as well. But we need to be thinking about, with all this water, what are we actually doing with it? And how can we be more sensitive with our actual urban design to capture a greater proportion of this rainfall? Because it wasn't just a few years ago that this chart was completely inversed and the rainfall amount was drastically lower than our average yearly rainfall. And if we compare that to cities across Australia, I mean, obviously we've got people joining us from across the country, so I don't want to be the typical East Coast person who only focuses on Sydney. But you can see here that our rainfall amount actually differs quite a lot between some of our major cities in Australia, ranging from Adelaide, our driest city, at 590 mil, all the way up to sort of Brisbane and Sydney at your 1,200 mil average. So it really goes to show that, in areas such as Sydney and Brisbane, we really need to be looking at trying to capture that rainfall, to avoid flash flooding and to be able to actually service the needs of the growing populations in those cities. Conversely, in cities such as Adelaide, Melbourne, and Perth, where we don't get a lot of rainfall, we need to actually be a lot more smart about how we do use and how we do store the water that does fall in our cities. A lot of the time, what happens when it rains in these cities across Australia is that goes straight into a pit, straight into a pipe, and straight out to the ocean. It's the quickest and easiest way to get rid of that water out of our cities to reduce the likelihood of flooding. However, that comes with the negative effect of not being able to actually store and use all of that water that's falling on our cities. So as one mechanism that we can use to think about how to be more sensitive with, water sensitive urban design, permeable pavements are a key player in that. And you can sort of see my point illustrated from a couple of minutes ago. If you cast your mind back a few years to where we were in the, early 2000s into sort of 2010, we actually had, those large drought periods. And this is in 2018, even a few years ago. And then for the next slide, I had dealer's choice of which photos I could unfortunately use to illustrate the exact opposite of that previous slide, where in 2022, we've had flood event after flood event after flood event. So I think as Australians and as urban planners, we need to be a little bit more aware of how we're designing our cities. Our climate is changing. We're seeing that we're getting more erratic patterns of weather. And so because of that, we need to start thinking about different strategies to actually, design our cities in a more sensitive manner. And you can see here a couple of examples of this, swales, detention basins, but more specifically, the idea of permeable pavements. And, I've talked about the idea of water. I'm not going to delve too much into the idea of improving canopy cover. This is something we have covered in a previous webinar, and I'm happy to talk about this in a future webinar. But again, there is a really beautiful relationship between permeable pavers and trees. And they actually can assist with the growth of trees, which is fantastic for not only improving canopy cover, but also reducing the urban heat island effect. This is a really great heat map or a thermal map that the City of Port Adelaide Enfield actually commissioned. So shout out to anyone that's here from that council. They've been doing some great work with monitoring how they can actually, reduce the actual daytime mean surface temperature. And you can see what I sort of want to illustrate here, if anyone's familiar with Adelaide, you can sort of see the areas where it's highest, where the temperature is the highest, is generally those built up urban, city centres where you have your shopping centres and you have your car parks and you have your higher proportion of darkly paved surfaces, primarily with asphalt. And you can see here this graph on the right-hand side illustrates the sort of difference in daytime and nighttime heat flux between different paving products. And you can see there that asphalt and porous asphalt both, have that dark color, which means they have that sort of higher solar absorbance, which is associated with having that, higher urban heat island effect. Conversely, the beautiful thing about PICPs is they come in a range of different colors, and you can sort of manipulate those to suit your needs and reduce that urban heat island effect. So now it sort of comes to the idea of, where can we use PICPs and what are the best applications that we need to start thinking about now to get these into our communities. Again, I've pulled out a few examples here of where they have been used previously. And, if you have a bit of a look at these different examples, you can see that they're more or less used in a range of applications, from anything such as a domestic driveway all the way up to factory and container yards. We've actually seen port facilities being built using interlocking permeable segmental pavers. There's one in New York at Howland Hook that's a really great example of using a technology such as permeable pavements in a really high strength scenario. What I want you to all really think about today, and it goes back to my point that I made about the heat map we just had on screen, was the idea of car parks. A stat that I pulled off the internet a few weeks ago was that surface parking lots alone cover more than 5% of all urban land in the United States. Now, as Australians, we like to think of ourselves as better than the US, and we like to think that we've got all of our things sorted. I'm sure that number is slightly lower in Australia, but I'm also sure that our adoption of permeable pavers in Australia is a lot lower than the US. So what I encourage you to all think about, as a take home and something to have in the back of your mind today is that, what are the low-hanging fruits and what are the opportunities for permeable pavers, not just PICPs, but your no-fines concrete and your asphalt as well. Because there's really no reason in Australia why we should be designing asphalt car parks anymore. There is a place for these systems where we can be using our paved areas as a water-sensitive urban design asset and using that in our favor to either reduce and control flooding or improve the quality of our water or actually store that water for later reuse. So something to think about during the remainder of this webinar. So we've sort of talked a little bit about the uses and, the why and how of permeable pavements, but now it's time to get into a little bit of the nitty gritty behind, how we actually go about designing and specifying these pavements. So the sort of first step is to kind of have a bit of a look at a flow chart and, the engineering design methodology behind pavement design, specifically permeable pavement design. And you can see here that with regards to, our design considerations, there's sort of 3 key steps that we need to fulfill to have a pavement specified and designed correctly. And it sort of starts off with, your pavement type selection. So this talks about, your subgrade conditions. It talks about your type of cross section and what type of system you like, as well as the pavement materials. So both your base course material, as well as your actual paver and upper surface layer material. We then would go down into, your hydraulic analysis, as well as your structural analysis. So we're going to sort of look at step 1, and we're going to look at subgrade conditions, as well as your pavement cross-section. And the reason I've sort of circled both of these options in this flowchart on this slide is that they really come hand in hand. And a lot of the time, your subgrade or your soil conditions will dictate the type of approach you'll use with regards to a PICP system. Now you can see on top of the screen here, there's 3 sort of key types of systems that we can employ here for a PICP. There's a full infiltration system, a partial infiltration, and a no infiltration system. As engineers, we like to keep things pretty easy to understand, and the definitions for these are quite inherent to the function that they perform. So as a sort of first step, we can look at our full infiltration PICP system. And as you can see here on the screen, and as the name suggests, the idea of these systems is that we don't actually have any subsurface drainage infrastructure. And what actually ends up happening is that any water that enters that pavement system through your upper layers will actually end up translating through your bedding material, through your base course, and back into your underlying subgrade. The beauty of this system is that you don't actually have to have that drainage infrastructure. You don't have to put in your pits and pipes. And another beauty of this system is that it goes straight back into recharging your groundwater resources. So if that's a concern, then that's something that these systems can be used for. And you can sort of see the final dot point there that's sort of underlined on this slide is that these are used when you've got a subgrade that's a non-cohesive granular material. So something such as a gravelly or a sandy soil. And I'll get a little bit further into that in more detail as we progress. But you can sort of see the different sort of pieces of the pavement in this cross section here. You can see the actual pavers themselves. You can see the base course, the laying course. You can see the subgrade, which is, your underlying soil. And you can see your curb on the right-hand side as well. And I'll speak to all of these as we move through the design. Your next different type of cross-section that you could opt for if you're specifying a permeable pavement would be a partial infiltration system. And again, no shock, as the name suggests, this allows for some infiltration into the subgrade, but it also allows for some water to be captured and either stored or pumped out of your pavement system. And you can actually see that in these cross sections that we've got on screen here. You can see that the key things that you'd note is that you have a permeable geotextile or a sort of filter fabric that allows you to separate your base course material from your subgrade material. But that also still allows that water that's in your pavement cross section to get through to your underlying soil. What you also have here that's different to your to the previous slide is that you have a pipe and you have, in some cases, a pump as well that can be used to pump out or take out that water and reuse it for an alternative application. And so what we generally mean by that is we'll insert a slotted ag pipe at the lowest point or at the bottom of our permeable pavement cross section. And what ends up happening is you get this twofold movement of water, or two pathways, where one of them is that water going down into your subgrade, and the other is that excess water that you don't want going into your subgrade getting removed via that pipe. And you can sort of see these will be used in some clay soils and as well as some sandy soils as well. But you'll see where the sort of difference lies over the next slide for your no infiltration system. And again, as the name suggests, for a no infiltration PICP system, you have an impermeable membrane that actually basically borders your whole system. And this doesn't allow any water that enters your pavement system to exit into the surrounding subgrade. And so this really, if we're talking about analogies, this really is almost like the bathtub that I was referring to at the start of this webinar. You get basically this detention basin essentially that can store this water, and then you insert your drainage pipe and or your pump, and this essentially takes away all of your water that enters this system. And you can take that away to a different part of your actual stormwater infrastructure, or you could actually take that to a tank and you can use that to water your gardens, water your footy ovals, as a really nifty way of recycling any water that enters that system. So where you might use a no infiltration system is where you've got contaminated soils or where you've got expansive soils, such as your highly reactive clays. And that'll just mean that you don't have that water or that excessive moisture entering that soil to cause that heave and cause that expansion and contraction. And you can sort of see here on the screen a little bit of an idea of some examples where you might opt for different infiltration mechanisms. And it essentially looks at the permeability of the subgrade, or the ability for that subgrade to absorb your moisture. It also looks at how high your water table is, and looking at whether you need to adjust your pavement design to take that into account. And it also sort of summarizes that idea of pollutants in the subgrade as well. And you can see that in all of these scenarios, your no infiltration system can be used, but in certain scenarios as well, to sort of reduce the cost of infrastructure and reduce the cost of your pavement system, you might be able to opt for a total infiltration or a partial infiltration system. And you can sort of see that note there on reactive soils. In reactive soils, a no infiltration system is recommended because that will reduce the likelihood of getting that subgrade movement and that subgrade reactivity. And you can sort of see a little bit of an idea of the different types of subgrades that we might sort of, come into contact with when we're looking at designing our pavement. And I mentioned that these subgrades are very much related and inherent to the type of permeability of your subgrade, as well as the type of system you'll specify. And you can see that, with your heavy clays, which I was referring to before, and your silty clays, you don't have that permeability, but you also don't have the actual typical subgrade strength, which is measured in your CBR, or your California bearing ratio. And so essentially with these systems, with these clays that are likely to react, we'll go with that no infiltration system. Conversely, with your well-graded sand and your well-graded sandy gravel type soils, you're much more likely to have a higher associated subgrade strength, and you're much more likely to be able to absorb that water entering the system without the danger of that sort of reactivity and that sort of movement occurring within your soil. And so in those scenarios, it might be completely fine to specify a full infiltration system. And that can obviously save you a lot of money depending on, what you're attempting to do with your permeable pavement system. And in terms of pavement materials, we've sort of talked a little bit about now our subgrade conditions and our pavement cross-section and the different types of cross-sections we can opt for. Now it's time to talk a little bit about pavement materials itself. So within a pavement, you obviously have your base course, you have your bedding course, you have your actual surface layer or your pavers themselves, and you have your jointing material that actually is poured between all those joints within the individual pavers. And all of these things are really important to think about, and they do differ quite a lot to your conventional segmental pavement. So it's really worth taking note of the different types of choices you'll need to make with regards to pavement materials. First thing I'll talk about is this important relationship between strength, compaction, and void ratio. And the idea that, as your base course strength increases, generally speaking, your void ratio decreases. And that means that your ability to hold water decreases. Similarly speaking, if you have a high void ratio, you will be able to hold more water that enters that system, but you won't have the associated sub or base course strength that you might desire for. So again, it becomes a bit of a balancing game between picking a base course material that can hold the amount of water you want to enter the system, but also be strong enough from a structural perspective to actually withstand all of the traffic loadings that your pavement is going to be subjected to. And you can see here that sort of table on the left-hand side there of this slide talks about some of your different granular base materials that you might be able to specify, as well as some of your cement-bound materials. And you can sort of see the idea of what the void ratio is of that material, as well as what the typical strength modulus of that material might be. And, as a general rule of thumb, you can, assume that a permeable granular base course material will have about half the strength of your conventional base course material that you would use for a regular concrete segmental pavement. But obviously, depending on the material that you can source and depending on the grading of that material, that will both alter your void ratio as well as the strength. And that will then alter the cross-section and the thickness of your permeable pavement, which we'll get into in a little bit. And you can see that idea of some common base course materials, as well as the grading for those materials and the grading curves that are available for those materials. As you can see, for example, if I draw your attention to the fourth column, or the column number 3 in this scenario, for a single size granular base material, you can sort of see the different percentage passing a sieve for a different grading, or for a different associated grading of that base course material. So we get a lot of questions here at the CMAA about, if you're not able to source this exact grading, can you use an alternative grading? Can you use an alternative base course material? The answer is absolutely. You can, provided that that material, first of all, is strong enough and can hold the amount of water that you need it to. So I know that we've had some questions, particularly from people in Perth, that have sort of struggled to find this grading. And so the answer is, if you have different materials available, you absolutely can use those, but you just need to have a bit of a look at how that's going to perform from that strength as well as water holding capacity perspective. And you can see there's a variety of materials here as well. It's not just your single size granular-based material. You've got different materials, including, your cement-bound permeable materials that can be used as a base course material. And it's dependent, again, on what you as a designer want to specify for that pavement. So again, in terms of base course material and subgrade material, looking at how we actually compact that material. So we've gotten a lot of questions about whether we compact that in a similar manner to a conventional pavement. And you can see here that for a trafficable pavement, that sort of graph or that picture in the bottom left-hand corner here, you can actually see that there is some guidance for the amount that you need to compact your pavement layers if it's going to be trafficable. And by trafficable, I of course mean if it's going to have vehicles using that pavement. And you can see here that for different materials, for your subgrade, you'll need to compact up to 92 to 96%. For an unbound base material, you might need to compact to 98%. What I will say to this note as well is that, I mentioned before that there's a relationship between permeable pavements and trees. And if you're looking to have trees growing adjacent to your permeable pavement, you might find that this value may need to actually change to allow that tree to grow healthy roots. And so what I will say to you here is that, as a designer, it's up to you to determine whether or not you can get away with having less compaction for that tree. But generally speaking, this is where, I would say as someone working at CMAA, that you can actually have a bit of a look at that and maybe come up with a novel solution where you have a pedestrian pathway adjacent to these growing trees next to, let's say, another permeable pavement that's actually compacted for trafficked applications. So generally speaking, our PE01 manual in the CMAA has some guidance on how you might, treat your sub-base, subgrade, and base course layers with regards to compaction to ensure you're getting the strength, but also to ensure that you're still getting that water holding capacity that your pavement will need. So we've talked a little bit about pavement materials and some of the types of materials that we can use for our base course and for our structural base course that will often, form the base of our structural system. But obviously that's only, a small portion of the system itself. We need to think about the actual pavers and we need to think about the bedding and jointing material. So with regards to those, there's myriad options available. And this is where I would defer back to your manufacturers. Depending on what type of look you're going for, these pavers will influence that. But they also influence your increasing infiltration rate as well. So, depending on the type of paver you actually select, this will actually influence your infiltration rate into your base course materials. And you can see that, essentially speaking with that Eco Trihex at the top, it's got those really large joints filled with your jointing material. So it can generally take a lot more and have a higher infiltration ratio or infiltration rate. Now, again, in terms of actual specification itself, it's worth noting that when you're looking at your paver, you need to, again, make sure that it's going to do the job required for whatever application you're putting it in. And this table is taken from our PA03 manual, but it's also taken directly from the AS, the Australian Standard 4455.2. And it actually shows you, I'll draw your attention specifically to the work size minimum thickness column right in the middle of that table. And it tells you that, depending on where or what application your pavement is serving, that's the minimum paver thickness you'll need for that application. And you'll see here, as a good example, for a public space with pedestrian and commercial vehicles, you'll need to have a paver that's at least 60 millimeters thick to withstand the loading that's going to be subjected to. And, you might think as well, if you're designing a pedestrian pavement, you might think, oh, that's fine, I can use a 40 mil paver. But I urge you to think about the idea of whether that pavement will ever need vehicles on it, whether that's to clean the pavement, to sweep it, emergency vehicles. And the answer is, if you're ever going to have a vehicle on that pavement, then generally speaking, that's now become a trafficked pavement. And you'll need to select the appropriate thickness paver for that application. So just something to be aware of when you're looking at what a pedestrian versus a trafficked pavement actually is. Now, the next thing to consider, if we've got our base course material, we've got our paver material, it's now time to think about bedding and jointing. And what I mean by this is bedding material is the essentially material that you will lay your pavers on. That's the material that they will sit on. And jointing material is that material that will fill each of those individual joints between the pavers. Generally speaking, a 2 to 5 mil uniformly graded aggregate is what we would recommend here at the CMAA for a permeable pavement. For a jointing material, you could also use the same. You also might be able to use a 1 to 3 mil aggregate, which has been used popularly in Europe. My one piece of advice here, if you take nothing else from this slide, is do not specify sand in your jointing or your bedding material, because sand doesn't have the void ratio necessary to quickly absorb that water fast enough to get into your pavement system. And that essentially acts as your point where your pavement will itself clog up and it will actually cause pooling on the surface of your pavement. So remember, in a conventional pavement, it's fine to use sand for segmental pavements, but for a permeable interlocking concrete pavement, you need to be looking at using an aggregate, because that will give you the required infiltration to get that water into the system. Now, a common question we get here at the CMAA, my number one question is, and it's a great question as well, but it's, will they clog over time? Will your permeable pavement in those upper layers, as leaves fall and as people drop cigarette butts onto the pavement, will all of those small little gaps eventually become clogged up with organic material and pollutants, so much so that it won't be able to infiltrate that water fast enough into the base course? And what we actually do here with the software we have at CMAA, and what most pavement engineers will do with regards to these interlocking pavers, is that you'll see this sort of green trend line showing the infiltration rate over time. And you can see here that essentially you get almost like an asymptote, that at about the 10-year point, or about the 15-year point, you almost reach a terminal clogging situation that gets to about 10 to 20% of the original infiltration rate. And that value, that conservative value at the 10-year mark, is what we will actually use as our ongoing infiltration rate for our pavers when we're designing a segmental pavement. So what essentially ends up happening is that when you lay the paver, during the first year, it's actually overperforming by a very, very high degree. And then, over time, it'll slowly naturally clog up. But again, that's not taking into account any maintenance. If you're sweeping your pavers, every 6 months to every year, that value immediately goes straight back up to its peak infiltration rate, or close to that peak value. So it's a good question to ask, but the answer is, if you design them for a conservative value of infiltration, then your pavement will perform above that value at all times, and you won't get that associated clogging. Just another thing to think about as well with regards to surface is a sloped pavement, and how do we treat a sloped permeable pavement. And this is a really great example here from the National Ready Mix Concrete Association, I believe, in America, where they show some of the examples of what you can do with a sloped permeable pavement. And you can actually put in these sort of barriers that will separate and, mitigate the idea of getting that uneven ponding in your pavement surface. And, using these terraces and baffles can be used to separate that water outward. As a general rule of thumb, we recommend that a 5% maximum slope be used, and anything more than that, get some design advice and determine whether or not that system's going to be feasible. But generally speaking, anything between a 1 to 5% slope is permissible for a permeable pavement, and it's quite easily achieved. So we've done our pavement type selection now, if we're going back to our flowchart. So now it's time to think about our hydraulic analysis and talk about what our system's actually trying to do. So you can actually see here there's sort of 3 options of what a permeable pavement can specifically be designed to do. There's flood control, pollution control, and water harvesting. And I'm going to touch on all of these. So firstly, runoff control. How does it work? So again, this is probably going to sound like I'm repeating myself, but it essentially acts as a stopgap. Your PICP, your bathtub or your detention reservoir, essentially takes into account all the rainfall that's getting, falling onto that system in a precipitation event, and it's storing that rainfall so that it can slowly release that rain either into a pipe or into a subgrade below over a longer amount of time. And so we're essentially extending the hydrograph. And by extending the hydrograph, we actually reduce the likelihood of getting a minor or a major flash flooding event. And again, the Demio software has limited me here. These are supposed to be GIFs that actually show the pavement filling up. But I'll encourage you all to use your imagination and imagine what's happening where this rainfall slowly fills up the pavement, and then it stops raining and the pavement is still full, and that eventually will actually go down that pipe and slowly be released either into your subgrade or into an existing stormwater system. And you can see there on the left-hand side that idea of the permissible discharge, that red line, and the actual outflow out of your system, that yellow line. And the idea is if your outflow is below your permissible discharge, then you have a system that is reducing the effects of having that flood event occur. Second one is water quality improvement. Obviously, all local government areas in Australia just about now have water quality targets that they need to meet with regards to any water that they're pushing out into their stormwater systems or into reservoirs as well. And the idea of a permeable pavement, specifically a PICP, is that it works through mechanical filtration. And essentially, the water falls down your pavement system, and any of those pollutants, those small TSS, nitrogen, phosphorus, that'll almost attach onto all of those sharp angular pieces of base course material, and you actually end up getting a cleaner water coming out the other side. So think of it almost like a Brita filter. And essentially, any of those pollutants that remain in the base course can be broken down through bioorganic action. So you end up getting essentially a big water filter, and dependent on the reductions you're trying to meet, so depending on what pollutant load you want to reduce, you can actually alter the thickness of your base course and alter the length of your filter, so to speak, to reflect that. And finally, water harvesting. I mean, the idea of this one's pretty easy to understand. The idea is that your pavement system is your storage tank, and it essentially takes your water, and then you can pump that out and you can use it to, put into a water tank and water your gardens and water your ovals. And again, the idea is the thickness of your base course determines the actual amount of volume that your water, that your system can store. And so you can alter that to fit how much water or what your water demands actually are for that system. And the great thing about all of those sort of three different types of systems is they actually all sort of work in combination with each other. You can obviously design a system specifically for one of those, but inherently it's going to perform pollution control and it's going to harvest water at the same time as reducing the likelihood of a flood event. And the beauty of all three of those is that there's actually a software available that you can use to design those, to actually determine what your base course thickness is going to be. And in the interest of time, I'm going to go through Design Pave and Perm Pave in a sort of expedited way. And I'm going to give you a bit of an example as to sort of how it might be working for a runoff control option. So if you remember going back to step 2, there's flood control as an option for what your pavement function can perform. I'm going to show you how that might sort of present itself and how that might look. You can see firstly here on Design Pave on the actual software, it gives you all three of those options as sort of, your main hydrological testing methodology. So you could select runoff control. And essentially the way it works is that it uses data from the Australian Rainfall and Runoff Guidelines, and it'll actually use your IFD curves from, at this point in time, the major capital cities of Australia. But in future revisions of the software, we're going to hopefully have IFDs across the whole country. And you can actually use those to assess what sort of design storm your pavement needs to withstand and how thick your base course needs to be to actually withstand that amount of rainfall. And the design methodology is really quite simple if you break it down, actually. It's basically a bucket with a hole in it methodology. So you're filling a bucket and it has a hole in it. And the idea is that you want this bucket to be large enough so that it can handle all of the inflow while still being able to have that constant outflow and not overflow. If your bucket overflows, your pavement has pooled and your pavement has failed. And that's the sort of methodology that the software uses to model the pavement. And you can see some screenshots here of how it sort of works. And again, if anyone wants a demonstration on DesignPave and PermPave specifically as a next installment of this webinar series, that's something I'd love to do. So feel free to let me know. But you can see here, you can enter some of your different storm durations, and you can enter whatever your target peak outflow is, or you can enter a runoff coefficient, and it will essentially test your pavement inputs. It'll test whatever pavers you've put in. It'll test whatever base course material you've put in, whatever bedding course you've put in, and it will tell you whether or not your pavement will perform from a hydrological perspective. And, if it doesn't perform, if it fails, it will tell you to actually go back and adjust those parameters so that it will actually work and so you won't get that pavement failure. And the same is true for both the water harvesting as well as the water quality. You'll input your parameters for your thickness, you'll input your parameters for your, target coefficients, if you're reducing your pollutant loads or if you're trying to store a certain amount of water, and it will tell you whether or not your pavement's going to perform from a hydrological standpoint. And again, you can actually see, a bit of a summary of that. This is that same hydrograph that I pulled earlier, but you can see that the goal, regardless of the hydrograph, is to ensure that the outflow never exceeds the discharge. And that's that idea of the bucket with the hole in the bottom. And so if you achieve that, then your pavement will work for that given design storm and it will perform for that given design storm. And so depending on the type of asset you're designing, whether it's a driveway, whether it's a car park, whether it's a road, you might have different design storm conditions, different exceedance probabilities that you'll need to actually take into account. And again, the beauty of the PermPave system is that it actually, again, takes into account all of those different exceedance probabilities to allow you to calculate for different types of assets. And the last thing to sort of think about with regards to runoff control is that, you don't actually have to have all of your pavement area be permeable. If we think again as permeable pavements like a drain or like a bathtub, this diagram in the bottom right sums it up really well. But you can actually have a large area of impervious pavement, whether that's asphalt, concrete, conventional segmental pavement, and you can have that all directed onto your permeable pavement. And again, the beauty of this is that you can use some really easy equations to calculate the amount of volume of water that would fall onto that area. And PermPave actually does that for you. You can actually enter what your areas are, and it will tell you again whether your system can withstand those different amounts of rainfall, depending on what your ratio of impervious to pervious areas are. And again, as a sort of rule of thumb, there's a recommendation out there that says that your ratio should be about 2 to 5, pervious to impervious. And you can sort of see an example of this. You might have a footpath directing onto a segmental permeable pavement that absorbs all the water from both. But similarly speaking, you could really alter this ratio to whatever you wanted, provided, again, that you get a system that can withstand the amount of water that's falling onto those systems. So you can have a bit of a play around with those different volumes and determine what's actually going to work. So as a final step now, we've talked about our hydraulic analysis, and we know that our pavement now works from a hydrological standpoint. Now we need to make sure it performs from a structural standpoint, and we need to make sure that it's going to withstand all of the loadings that are going to be placed or imparted onto the pavement. Now, permeable pavements are generally modeled as flexible pavements. This means that you'll get that deformation applied locally, and it's going to be distributed to a much smaller section compared to a rigid pavement, such as your concrete pavements. And you can see here, these are some diagrams showcasing how, those loads are actually dispersed onto the actual surface layer of a segmental pavement. And this is the same for impervious as well as permeable pavements. And you can basically understand that the larger the depth of your base course, the greater the zone of influence, which means that you basically have more capacity to withstand those heavy loads. So the CMAA, and we did some research before, in previous years, and we found that the failure criteria for flexible pavements that's modelled in Austroads is actually not representative of a segmental pavement specifically. And instead of that, we recommend, and the DesignPave and the PermPave software that I'm talking about actually uses a shell design procedure for segmental pavement design, which actually we find models how that pavement performs in a better and more suitable manner. And what it essentially does in a layman's perspective is that it converts all of the layers within that pavement to an equivalent thickness of your subgrade material. So it essentially manipulates those thicknesses out using Odemark's theorem, and it actually will put it out into one cohesive thickness for you, and then you'll be able to do your stress and your strain calculations to determine whether your pavement thickness is able to withstand those loads. And again, I'm not going to get into the nitty-gritty of all of the back-end analysis of it, but all of this is available for you to have a look at and understand the formulae and the equations behind how it works. But you can use the Boussinesq stress theorem to actually impart all of those vertical, radial, and tangential stresses to determine your amount of repetitions or the amount of traffic that can be subject to your pavement. So what I sort of mean by this is, you can sort of rearrange and manipulate the formulas to actually get your allowable number of strain repetitions on that pavement. And that can translate to the amount of repetitions you might have using the pavement system over its intended design life. So how that sort of looks really quickly from the front end is that you can essentially impart your equivalent standard axles, so the amount of traffic that you're going to have subjected to your pavement, or your annual average daily traffic. If you have a traffic spectrum of who's using the road or who's using the car park, you can actually input that. And then based on your subgrade, based on the strength of your base course material, based on the strength and the thickness of your pavers, which we've already decided, in previous slides, we've already decided our paver, we've already decided our base course, we've already decided, we know what our subgrade conditions are. It can then actually calculate your base course thickness to withstand those allowable repetitions or that traffic that you actually want your pavement to actually be able to model for. So a little bit, it's a lot of information to impart, and I encourage you all to have a bit of a look at the PermPave and DesignPave software and ask us any questions that you might have regarding the software. But what does a pavement actually look like? What do these look like when they're completed, and how do they present themselves? Just a few examples to finish this off. This is a case study that we showed off to the City of Canning in Western Australia of the Adelaide Oval Fig Tree Plaza. And you can see basically a before and after of what this system or what this environment looked like. And essentially they wanted to make a pavement that would actually be able to take in and infiltrate all of the water falling on that pavement system to be actually able to help those trees grow and promote healthy tree growth, as these trees were over 100 years old. And so what they actually ended up doing was using permeable pavement system, using some Adbri masonry eco-trihex pavers, and actually allowing those trees to remain and not cause that uplift that trees can sometimes cause with conventional pavements. Another example that sort of talks to what I spoke about at the beginning of this webinar is the idea of using them for shared zones. So again, this is a project in West Perth where they wanted to have pedestrians and traffic, using the same zone and interacting with each other in a safe way. And they found that pavers themselves, through their patterning, actually created designated zones for pedestrians and cars. And the idea of the permeability also allows it to act as a water-sensitive urban design asset as well. Personal favourite of mine, this is a project in West Torrens in Adelaide, and this is actually a pavement with all of these trees lining the street. And what the engineers and urban designers did was they actually modelled the pavement to sit directly underneath the drip line of all of the trees in the street, so that any water that hits the trees and intercepts through to the ground will actually be recycled into the pavement. And that can be used to recharge and assist with the growth of all of those roots for the trees right next to the pavement. And another one from the City of West Torrens as well that was actually a high commendation in our Think Brick Awards would be this idea of the River Red Gum project. So these are some, again, over 100-year-old river red gum trees that are actually sitting right in the actual street of a residential street. And instead of laying down a conventional asphalt pavement that would have caused uplift and actually inhibited the growth of the tree, what they did was they used a permeable pavement system with a sort of geogrid that you can see there on the left-hand side that gives more strength to the pavement system, but it also, again, allows the actual pavers themselves to intercept that rainfall and use it to water that tree through the ground underneath the pavement structure. So look, just a little bit of a summary of now what you know as we're sort of nearing the end here at 12 o'clock. You should now know the idea of what a permeable pavement is, where and how they can be used, and some of the benefits, as well as some key specification and design parameters that you need to be aware of, specifically the materials that you're going to be using for a permeable pavement, as well as the associated design process for a segmental pavement, whether it's a hydrological design or a structural design. So you can actually sort of see how they work. And a little bit now, you understand how the Design Pave and the PermPave software works. And again, this is something that I'd like to touch on in further webinars, so I'd encourage you all to attend those and have a sit in on those. Now, my question is probably a little bit, what do you want to see next? And I've got a poll up here that I'm happy for you to all answer. I'm happy to cover detailing of permeable pavements, more case studies, integrating PICPs into driveways, more topics on Design Pave and PermPave software itself, which I don't think I've put in the poll, but if you want some of that, please let us know. And we're happy to touch on that in future webinars. So look, where I'll sort of finish up now is that you should be able to register for Design Pave using either the link that I can see Keanu's circulated in the chat or through the QR code that's on the screen. I'll give you a quick minute to have a bit of a look at that. While that's doing, I'm just going to quickly look at the questions now. I think Keanu's going through and answering most of them, so thank you, Keanu. Steve's got a great question on any comparisons of embodied emissions in PICP systems versus conventional systems. I believe there are some out there, but none that are Australia specific at this point in time. What we're attempting to do at the CMAA is actually try and commission a bit of a study there that actually looks at what the embodied emissions are of those two systems. What we do know is that generally the maintenance requirements for PICP systems are a lot lower than your conventional asphalt systems, if it's designed and specified correctly. So the idea of embodied versus recurrent emissions, we're likely to find that in a segmental system, whether it's permeable or whether it's a conventional concrete segmental system, those recurrent emissions are likely to be lower. And there's other questions as well. I'm going to let Keanu keep answering them along, but please keep the questions coming as we're here to stay. Ben, we had a project in Perth where a permeable pavement with no drainage was more expensive than an asphalt pavement with drainage. It was for a car park. How can we reduce the cost of permeable pavement so they use more? Look, Ben, that's a fantastic question. And again, it comes down to sometimes where the right pavement is for the right job. I know that we found before a project in Adelaide in Melrose Park where it was going to cost them over $1 million to redo a whole street with conventional asphalt and drainage infrastructure. And they found that they had this sort of inverse relationship to your project. They did a project with permeable pavements, and it's on the Water Sensitive Urban Design, Water Sensitive SA website. And they found that pavement project saved them, I think, over $220,000. So again, I guess it comes down to what solutions you can employ. And what I would recommend for a car park as an introduction to help get these systems online is, doing a combination of permeable and impermeable pavements. Maybe use a permeable pavement system for some of the actual car parks themselves, and actually have that as a partial infiltration system that you can connect up to the existing stormwater system, or have certain pieces with the asphalt that direct onto that actual car park system itself. So I guess it depends on how you can get that low-hanging fruit. And I think the other idea that's really important as well, that's probably quite poorly communicated from the industry's perspective, as well as our manufacturers, is that the associated maintenance costs with these systems is a lot lower than a conventional asphalt system. Generally speaking, for a PICP system, we can sweep that system once every 4 to 6 months, depending obviously on the environment that it's in. And we'll generally find that after years and years of having that system down, you'll actually sort of break even, comparatively speaking, to your asphalt system. We have some reports that are actually being commissioned in the UK that showed that relationship between ongoing maintenance of both impermeable concrete segmental, permeable pavements, as well as asphalt and poured concrete. So I think it's worth translating the idea of what the ongoing maintenance is going to be, as well as looking at how we can implement maybe small sections of permeable pavements to act as our water sensitive urban assets, in combination with maybe some of the more cost efficient options. And I can see Melissa's here from Water Sensitive SA. Thank you, Melissa. She does some absolutely great work over in South Australia with a lot of water sensitive urban assets, and she's actually showed the example that I was looking at with regards to the cost comparison of a permeable and impermeable system. So, and it's at this point in the webinar as well that I'll mention that based on all the questions that are coming through here, I can see that there's some questions about cost comparisons, as well as where to find design pave and some examples of different projects. I'm happy to send that through to everyone that's here as a follow-up email to this webinar, so that you can have access to all of those resources. So, yeah, and Ben, you're absolutely right with your comment there as well with regards to construction and maintenance. It's a barrier that we need to definitely try and tackle. So again, we're hoping that with more projects being laid down, we can do more research with the actual pavement systems themselves. Because bearing in mind, permeable pavements, we design them on the conservative side because we don't want them to fail. So we're hoping that by doing more tests with them in the future, we can actually reduce the conservatism applied with those systems. Because what we find is that there is a bit of a double standard for different pavement materials. The minute an asphalt system fails and floods and potholes, it's sort of generally accepted that system just does that, and that's an associated issue with asphalt. But the minute a permeable pavement system pools or floods, it's sort of dictated a bit of a failure by the surrounding community. So we're trying to sort of break down the stigma of how we can get these systems laid down, and how we can see more case studies showing what those designers did to actually make it more of a cost-efficient solution as well. Samuel's asked a question if we've got any examples for on a grade. I'll see if I can find any for you. I don't have any that I believe have been entered in our awards that are greater than 5%. So I'll see if I can find any permeable pavements that are on sort of more of a 5% grade that have that sort of baffle and the sort of different segmental slope pathway, and I'll see if I can send that through with regards to that email that I mentioned before. And Melissa's absolutely right, just in regards to the point that I made before about communication of water-sensitive urban design assets. I think there's a bit of a communication gap that industry needs to fill, and Water Sensitive SA is doing some fantastic things in that regard. I know that CMAA is heavily involved with some of their projects regarding, creating new resources for permeable pavements. So definitely keep an eye out both on the Water Sensitive SA website and socials, as well as the CMAA websites as well, because I think there's going to be some exciting stuff coming in the near future. I'm just going back up to the top as well to see if there's any questions that we've missed. Also, at this point in time as well, just while I'm scrolling through the chat and having a bit of a look at what everyone's commenting here, CMAA, we are a not-for-profit industry association, so we actually offer all of our programs on a complimentary basis, similar to this webinar. So if you want us to come to you and deliver a presentation on using DesignPave or on detailing permeable or segmental pavers, we're more than happy to actually do that. And I'm going to actually just put a little poll question up there. If this is something you're interested in, please feel free to answer the poll, and we're more than happy to send you an email and see whether we can tee something up for you in the future. Similarly speaking, we offer an approved installer program. So a lot of the issues we see with pavements themselves, whether it's permeable or impermeable, generally stem from either poor specification or poor construction. So this program aims to actually get engineers as well as some of the construction personnel together and do a bit of a workshop on how to actually fully go through the process of designing, specifying, constructing, and maintaining segmental as well as permeable pavements. So again, on our website, we have some links to the approved installer program. And the beauty of that is, again, it's a free program. We actually come to you and we sit down for a workshop during the day, and we'll sit down with whoever you want to get involved, and we'll actually send that out. Alrighty. Yeah, so look, just in sort of summary to the last couple of questions here, coming up to 1:15. Oh, I think Keanu's coming online now. How's it going, Keanu?
G'day everyone. I got a bit bored being the silent person in chat, just answering all the questions. I think it might just be easier if I just
go
comment
for it.
on
I'm
the
going to let
last
you
few
go while
ones.
I can have a water drink.
Let's start. I think Clayton's had one. Help push for PICP, and the government doesn't have a great rep. That's absolutely correct. Jack touched on it. There's been terrible instances of permeable pavements being used. That's the fault of engineers like myself, as well as, again, the manufacturers for not educating people along the way. We've learned a lot in the last 20 years. A great example was using sand in the permeable pavers. That came from South Australia. People like to use sand in your permeable pavements. In South Australia, they don't have those intense rainfall events that we do in Sydney. And so what happens is it works in South Australia. It does terribly here. So we're constantly learning, constantly improving our leading practice. But yeah, the best thing you can do if you're having difficulty pushing it up the chain is to get the CMAA involved. We have a lot of experience. We've helped a lot of councils start getting their specs up and running as well, and just educating their constructors as well. What will be the joint detail with other pavement types? That's a great question. We're actually working with the water sensitive South Australia right now to develop a standardized set of interface and edge details for permeable pavement systems. In the meantime, though, if you need advice on that, you can reach out to the CMAA and we can help give you a couple of sketches of what it should be looking like. But yeah, usually if it's an impermeable system, obviously you're probably looking at something like a concrete edge beam to separate that permeable and impermeable material. You don't want the water making its way into the impermeable system. No infiltrated systems could be used to help tackle legacy pollutant issues in the subgrade. Completely agree. Again, I'm not a hydrologist or a drainage engineer. Logically, it makes sense to do that. If you cut off the subgrade, you're not getting that contaminants flowing into your stormwater system. Having said that, again, it's a HDPE layer usually. So when you're looking at like long-term durability, that has to be questioned whether that is a long-term solution. But absolutely, it's something there. It's probably better than what we do now, actually, that I think about it, because when we do subsurface drains in impermeable systems, we also use a HDPE layer, so it must be quite similar. And then for treatment to help from sweeping. What other maintenance options are you unused in Australia? Generally, it's just the sweeping. Like all pavements, pavers become chipped, damaged over time. Replacement, spot repairs, things like that. But yeah, generally it's just the sweep is all you need. I think after maybe 10 years, if you really wanted to make that pavement really perform and it was designed close to that limit, you could just pick up the pavers and redo that bedding layer and jointing aggregate, but you wouldn't have to touch that base.
Yeah, and I think just one note on that as well is when you're sweeping, I think a lot of people will just put on the no vacuum. Yeah,
no vacuum.
Turn off your vacuum for sweeping, because a lot of the time we'll see vacuum sweeping and it sucks up all of the jointing material, which is associated with the actual strength and stiffness of the surface layer.
Some trial projects. Clayton, absolutely. Like the CMAA has that resource. We're big on it. Please do reach out to
I think this is something, just in answer to that, this is something that we are working on at the moment, Clayton. I mean, I was over in Perth in September and we were chatting with some of the manufacturers to see if we can get some trial projects and some well-documented trial projects underway. So that's something I'm definitely happy to speak to in more detail. Take that offline and send you an email and see whether we can get some. We've been working with the Arbor Centre in Perth as well on some of the information with regards to trees and permeable pavements. So it's something in Perth that we're really hoping to really get underway. I know that Adelaide is generally referred to as one of the sort of almost leaders with regards to PICPs. So we're trying to hope that that Perth and Sydney and the rest of Australia can catch up a little bit.
How long will it take the underneath layer with proper maintenance? So generally all of the contaminants or the clogging occurs in the jointing aggregate. That's why sweeping is a really good mitigation of that. Having said that, the bedding layer will eventually become clogged as well. The base layer realistically won't become clogged, okay? Because of the void ratio is so significant that the pollutant should theoretically not clog it up. Having said that, I'd say with regular maintenance, 20 years, right? And if I look at Sydney Olympic Park, I haven't seen them pick up the pavers in my lifetime. So, and that gets a lot of traffic. That has a lot of trees around the area as well. I think only maybe around trees you might be looking at about like 5 years, just because you are getting that extra silty, fine kind of material as there's biodegradable solids enter it. HDPE, so high density polyethylene plastic. It's basically just a plastic sheet. That's what we put underneath it. Sometimes you might put a cushioning blanket underneath, a little bit of bitum, and that prevents it from getting punctured. But generally, that's what we use as our impermeable liners, apart from, say, a concrete edge beam. Any recommendation on liner to protect water entering adjacent pavement? So I would always recommend, when you have an adjacent pavement, say an asphalt and a permeable pavement, you always need an edge beam in any case, because they're both flexible systems and you'll get issues with the interface if you don't have that edge beam, like a rigid structure retaining both of the pavements. So generally between two separate pavements, concrete edge beam.
Yeah. I think we've pretty much just got through most of the questions. I think there was a question from before about baffles for the slope pavements. Yeah, I think just a quick answer to that one. I think the ICPI, which is essentially the American equivalent of us, they in their details have specified they use concrete to actually poured or pre-laid concrete sections to form those baffles. Just as an answer to that question. You might know more, Keanu.
Yeah, I haven't personally used them, nor have I read much about them. I've generally been dealing with flat surfaces, but you can do like a sort of step system to I guess accommodate for more graded pavements. We wouldn't have any guidance on that from the CMAA. Maybe it's something we should be looking into, because Australia isn't flat. But I know the ICPI does have some guidance on that. So Jack, you can probably send that offline, or actually distribute to the whole group if they were interested.
So I think, look, in conclusion, and thanks for jumping on stage as well, Keanu. But in conclusion to Christina and Clayton from Stirling, I'll send an email off to you guys, and we'll see what we can get organised over the coming months. It's great to see we've got a lot of interest from everyone in Western Australia here. So I know that Ben's messaged as well. So we'll be sure to keep in contact, because it's something that we really want to push, and it's something that we both really believe in. So hopefully we can.
100%, and it's just lovely seeing so many people come out and actually joining a presentation like this. I think when we started out, we had about a quarter or something of this, and it's just something that's becoming more popular, especially with councils. South Australian and Western Australian councils really leading the way, and something we really want to bring across Australia, because we are a dry continent, and we do have a lot of issues when it comes to flooding. Flooding and drought, unfortunately. So
no, well, look, that being said, look, thank you everyone for joining, and look, again, if you have any further questions that you think of after this, you've got the emails on screen here as well, so we're more than happy to reach out as well. Also, I note your point there right now at the end here, Mohit, with regards to Seng. We're happy to collaborate, so I'll send another email out to you as well, and we can see if we can get this across to even more people. So thank you everyone for joining, and thank you, Keanu, as well, for doing a great job monitoring the busy chat that's been happening. So great to have this many questions, and thanks for jumping online right at the end here and assisting with the barrage at the end. It's been fantastic.
No worries, Jack. Thanks, everyone.
I'll leave the room open for the next couple minutes if anyone has any final questions, and I'll add them to the email that I'll send off to everyone in the coming days. So thanks, everybody.